Okay, so as the last presenter, I want to say thanks to everyone for a really great week. I'm self-taught in all of this, and I have like multiple questions I've had for years answered in the past 2 days, so it's been really great for me. So as Jason said, my name's Alahna Moore. I'm a master's student at the University of New Orleans in the Urban Studies program, and I'm currently working at a cultural resource management firm and also studying that in school. And I'm trying to apply digital means of preservation to vulnerable historic areas. So in this presentation, I'm going to talk about a 3D model that I made using a commercial UAS drone of a shotgun house in the Bywater Historic District of New Orleans. And I'm going to talk about also the broader implications of what this means for historic preservation, especially in Louisiana. Okay, so for this project, I'm taking a very different approach than all of you guys. I wasn't concerned about accuracy. I more or less wanted to see what is the bare minimum of what I can do in the shortest amount of time with no money, because as I said, I'm self-taught doing this all on my own. So with that, I was also trying to essentially establish a workflow of how this could be taught to people that are not photogrammetrists, that are not drone pilots, that are only people interested in conservation. So traditionally, I'll breeze through a lot of this because a bunch of it is redundant, of course. So traditionally, structures are documented using scale drawings and film photos, and those require a skilled operator and typically a team going out and doing measurements in the field. So that takes a lot of time, it takes a lot of money, it takes a lot of effort, and typically the products that are created are just stored in archives. They're only actually used by the professionals that are creating them and that are studying them. Whereas with photogrammetry, with 3D modeling, with laser scanning, that really opens a lot of doors for getting your data out there as well as what you can do with your data. So for one, the speed of scanning and the speed of photogrammetry is what I think is one of the most important things, especially here in Louisiana, because it expedites the amount of data that you can create. So with a small amount of time and a few very minimal skills and very minimum funding, you can generate functional models. And these models can be used to enhance curation, interpretation, and dissemination of information about cultural heritage. And you can also expand the audience of people who get to access your information. So one example, first of all, as you all know, 3D modeling can be done on any scale. This is an example of a worm trail pot from, it was excavated at Storyville a few years ago, and it's been locked in a box in UNO's archaeology lab. So I made a really quick scan of it, took me maybe 20 minutes, put it on Sketchfab, and now it's been shared with the whole department. They're all really interested in like the possibilities of this. I'm also trying to get it printed eventually. So again, this can be used for bigger structures, and it's really great for remotely located structures. This is the Irish Bayou Castle that's located, I want to say about 20 miles away. It's closer to Slidell. It's on the shore of Lake Pontchartrain, and it survived Katrina. It survived a couple different hurricanes, but it still is very difficult to access. It's about an hour and a half out, and it is also a residence, so you have to deal with that too. And this can also be used for preservationists. So this is an example of Preservance Lodge 3, which is in Cypress Grove Cemetery. It's been struck by lightning a couple different times, and so I was contacted by a woman who was doing the repair work for it in order to actually have a drone go up there and to actually just examine the crack itself. And I said, why don't I make a 3D model so that we can actually do the measurements of it? And this is in Pix4D, I drew the crack out, and it says that it's what, a meter or so? Okay, so again, like I said, breezing through all of this, UAS photogrammetry works in a pretty similar way as terrestrial photogrammetry or long-range photogrammetry, but since the sensor is so much closer to the subject that you're recording, you have a lot higher resolution of imagery and of your data outputs. So prior to the commercialization of the multi-rotor drone, photogrammetrists really didn't have a way to capture a 3D view in high detail of a structure because they were using airplanes, they were using helicopters, they were using cranes, things like that. So it was just a much more dangerous, much more labor-intensive process before drones were in the game. So there are two main types of drones, the multi-rotor and the fixed-wing drone. I typically use multi-rotors for 3D modeling because they have the vertical takeoff and landing aspect of them, and they can hover, which means that you have very, very, very precise control of exactly where you want the drone to be. However, the downside of that is that their flight time is a lot lower because the motors weigh a lot, the cameras weigh a lot, and Yeah, it's a higher payload, and so because of that, you get to fly less time compared to a fixed wing drone that only has a single motor. But you have a lot less control over where it is actually flying. It operates more like an actual traditional plane. So you need space to take it off. You need space for it to make turns, et cetera, et cetera. But it has a lot longer battery life. So multi-rotors, I believe, are best for 3D modeling. Fixed wings can be used for 3D modeling, but they're typically more used for large-scale mapping. I was going to mention how no one else had talked about Pix4D, and then all of a sudden, all 4 presentations before me did. So Pix4D is the software I have chosen to use. It's the premier program for specifically UAS imagery. You can create 2D data products like orthomosaics and digital terrain or surface models, contour lines, and vegetation indexes, as well as 3D data such as point clouds, textures mesh, and 3D point clouds. Or 3D PDFs, excuse me. So what makes Pix4D exceptionally powerful to me especially is its mobile app, Pix4D Capture. This software allows for the user to design flight plans specifically for 3D model generation. So using this app, the operator needs to draw a polygon on their phone of the area of coverage desired, select the type of flight that you're trying to do, and input the altitude and the photo coverage you're needing, and press go, and the whole process is completely automated for you. So the app sends waypoints to the phone, to the drone, telling it exactly where to go and exactly when to trigger the camera to make sure that your model is of good quality. And these are some photos of the app at work. This is the newest version. The original version only allowed you to do a grid or a manual flight. The newest version gives you these other options of drawing a polygon, doing a double grid, or doing an orbital flight. Okay, so with that benefit of use, there is the hefty price. So with the full version of Pix4D Mapper, a perpetual license is almost $9,000. An educational license is about $2,000 for a single computer. And so to kind of offset that, they give you some options for individual services where you can get just the thing you need. So this is only within the past 2 months that they've released all of this. As we've said many times before, the technology is just exponentially increasing and growing and developing. So this is very new that they differentiated the full desktop program from the separate little aspects of it. So you can buy Pix4D for BIM for about $10,000, and Pix4D Model, which is only modeling no 2D information, for $500 a year or $40 a month. For some reason, there's no yearly for Pix4D Model. And then with the mobile apps, you get 5 free uses of the grid flight planning, and unlimited once you get the software purchase. Also, I'm sorry it's doing this clicky thing. This is some ghost vestige of a prior presentation that I didn't know was going on. So for this, what I'm going to talk about is a case study of a house. I call it the Royal Street house because I didn't want to say my old apartment. I chose this specifically because of its location. It's the circular thing to the right is the Royal Street house. I put a star where we are right now for those of you who are not here to kind of orient yourselves to where we're at, and then a few other just neighborhoods around Louisiana. Or New Orleans, excuse me. So mostly why I selected it was because of its location, because as I mentioned before, I'm doing a lot of this with the coastal component in mind. So the house is located on the last block before the Mississippi River, as well as by the Industrial Canal. It's commonly called like the Industrial Harbor, something of that sort. So it is obviously very vulnerable to environmental factors. The house was built in the early 1900s, and it's constructed from recycled barge board. So as the boats were going down the Mississippi, they would deconstruct them and then build them into houses into the neighborhood. It's within a historic district. It's a third of a mile from the 2 major waterways, and it's 1 mile south of where the levees failed for Katrina. It's on the opposite side of the canal, so this house actually was not damaged in the storm. However, it still is kind of alarming to see how close it was and the devastation that happened there. And additionally, there's proposal to start dredging the Industrial Canal and widening it for more shipping. So that could in some way impact the structure, as well as remodeling this old Navy base right here, these 3 buildings. They're talking about making that some kind of residential Disney World cruise thing. So that could again affect the structure. Here is the house in Google Street View, and here's the house in Google Street View 3D, which I included just because I think it's really interesting that this is obviously something that people are very interested in. They're trying to work towards, but there's not really a way at the moment to do photogrammetry and to do 3D modeling on a large scale. So, a very basic methodology. You plan your flight, you press a button and fly it, and then you process your data. I mentioned previously that my goal with this was to just see the very basics of what I could get with the least amount of time, money, resources involved. So I was originally only going to do one flight, but I bought my new drone and I wanted to check it out. So the first flight I just opened the Pixel Capture app. At the time you couldn't do orbital flight, so I had to manually fly it, and I just pressed go with the standard or with the settings that were on the app when you first open it. Unfortunately, with that, it had me taking a photo. Originally with Pixel Capture app, it would just trigger the camera based on the distance the drone had traveled on the ground. So whenever, again, I opened the app, it was 1 meter by 1 meter distance, which doing an orbital flight meant there were tons of photos. I took 322, which is absolutely extraordinary. It took over 7 hours of processing, and as you can see in the bottom left photo, each green line shows a point or a photo in which that point was visible. So as we were talking yesterday, I can't remember exactly who said it, but you needed to have 9 viewpoints of an image in order for it to register, and clearly this one has a couple hundred. Compared to my second attempt, which the app has developed my drones a lot better. Everything was just better conditions, basically. So I was flying this one with a Mavic. Instead of doing the distance that the drone flies, now the Capture app asks you the degrees that you need between each photo. So with that, I did 10 degrees, ended up with only 36 photos, so 10% less than my original drone, but still about the same amount of time processing, which is interesting. Other than the processing time, the only real differences between the models is the one with more photos was very noisy. And however, it was a little bit better coverage because flying manually, I was able to fly lower versus doing it with the app, which set me at my lowest height being 40 meters. So for post-processing of this, typically with 3D models, you use ground control points in order to increase your absolute accuracy. While they're not necessary, they do almost always improve it. So typically, a rule of thumb is the error of your model will be about 2 to 3 times the accuracy of the coordinates you're using to georectify it. So if you're coming in there with an RTK system that's getting like sub-centimeter accuracy, you can expect that you're going to get about a couple centimeters of accuracy for your model. Versus if you're using Google Maps, which I did in this instance because, like I said, I was trying to do this no budget at all, that will give you, an accuracy of feet to meters because the accuracy of the satellite imagery you're using is feet to meters off. Also, one thing that can affect that is actually marking the points in the photos. The image to the right shows the photo marking process, so I used the corner of the stairs of the apartment as a ground control point. And unless you're actually able to zoom in as close as possible and click on the precise pixel where your ground control point is, you're going to be a few inches off based on that as well. So in using Google Maps, first you actually go to the satellite imagery, zoom in, and click on the point that you're using as a ground control point. You copy the coordinates and go to a website such as DAF Logic, which will give you the actual Z elevation. And again, all of this is interpolated, so this is introducing a lot of call for error into the process. But like I said, I wasn't really going for accuracy. I was looking for just quality of visual quality. So with the flights that I did, I flew an orbital flight as well as a grid flight as well as took terrestrial photos. But to get just a quick and easy, I only processed the orbital flights and did almost no editing on those at all. You may be able to see there's a telephone pole in the front right of the house. I cut that out in all of them, and I drew a processing area so you're not looking at the full thing, but that is the only editing that I did on any of the models that I'm going to show y'all. So with the deliverables Pix4D can give you, you can get raster imagery, elevation models, and contours. Not in this instance because I didn't do the grid, although that is an ortho photo, just to show you. And then you can do fly-through videos, point clouds, textured meshes, polylines, and shape files. So the point cloud is the primary form of 3D data for back-end users. Each point within the cloud represents an XYZ coordinate in space and has an RGB value associated with it. And so in using this model, metric information can be generated from almost any point on the surface of the structure without requiring prior measurements. And this file type can be generated quickly, stored indefinitely, and referenced back to whenever measurements need to be compared. So I added this photo just to show that one point. It gives you the exact coordinates of it, the 3653, that's in state plane feet, I believe. What's kind of tricky about point clouds is areas that are obscured. So for this, that banana tree means that measurements of the roof are going to be a little bit off. You can't really measure the window beneath the banana tree because it's obscured, and it just adds extra points you can click to. As well as the front has a bit of an awning and the back porch. Because those areas are obscured and because I did not use any terrestrial photos, they're kind of warped in the point cloud as well as in the model, and so they're not really valid for great measurements in those areas. The same issue exists on the opposite side of the house because it's got a fence within 2 feet of it. It's a very thin alleyway, so it kind of prevented what the drone could see near the bottom of the house, as well as my ability to take full coverage photos, terrestrial photos. And as we learned in this process, the quality of the model is really dependent on its surroundings. So the Royal Street House seemed ideal to me at first, kind of to prove a point about its location, et cetera, but then I kind of looked back at it and realized it's not so great because of all the vegetation around it, because it is in a dense urban area. All these things kind of led to a drawback. However, I want to say that my end result of a one-flight model is not the worst thing I've seen. Good enough, I would say. So this photo illustrates the excess noise with the original model, the one that used 300 photos. Because there were so many photos, I think it was basically connecting to shadows, trying to generate key points when there really were no key points there. So as you can see along the roof, kind of like around the cars, things that are moving, it's really bubbly and not pretty. So it's not a perfect model. However, for pure documentation sense, I want to say that this is like an interesting thing that this could be done by literally anyone who has a cell phone, access to a drone, and can press a button. So all of us are much more familiar with textured meshes. This is what is typically curated. This is not like this is the front end user kind of thing. So meshes are created by triangulating the space between the points, and the photos that are input to the model are stitched together, warped, and projected onto the model to give it a realistic sense. And this information can be easily uploaded and shared online indefinitely, endlessly. Some challenges that I faced, as I mentioned, were the urban environment. It obscured a lot of areas. There were a lot of loopholes to jump through, etc. The area is obscured because of the house. Like I chose this one because you can really see that beneath the awning it very much just warps up, turns into a bubble because there are no points there. So the point cloud or the software tries to connect to the nearest point. Other issues that I faced was weather. I was kind of like planning this, had to keep pushing it back, which is not a big issue for me at all, but would be really difficult for people that are doing this professionally. Additionally, why I was approaching this was the idea to have a tool set as well as a skill set that could be easily taught to people and easily picked up. And I kind of realized in doing that it's not quite as easy as I make it out to seem. You do need to have a very basic understanding of a drone, the laws associated with it, and like what could go wrong, as well as how you do the processing and things like that. So that's something that I think as the software gets more commercial, more accessible, more people are going to start learning about it, be able to understand it better, and be able to talk about it more, you know? So additionally, another thing that I think is a challenge is the evolving government regulation. It's kind of a daunting thing for people that want to get into this but don't want to sign up for a certification, sign up for something, and then a few weeks later have to change that all up again. So that's something I think is interesting. And then to bring all this home, I wanted to explain to y'all why this is something that I do care about and why I'm passionate about it. In Louisiana, we're used to seeing these things, we call them red maps, which every few years the Coastal Protection and Restoration Authority comes out with these maps, and it illustrates what land loss and what land gain Louisiana is expected to experience in the next few years. This is with no action at all. All that is red will completely disappear. It already is holding on by a thread, but it'll be completely gone. So I added this because the first star to the top, I don't know why the text is blacked out, but the first star toward the top is New Orleans, and the star toward the bottom is the town that I came from, Houma. I grew up there till I was 18, and looking at this map, that's something that is realistically not going to exist in a very recent time. And I mean, Florida's represented here. We have a lot of people who are from coastal communities, and I'm sure it can feel the uncertainty and the fear that comes with the space that I grew up in is not going to be there whenever I'm an adult. It's not going to be there whenever I have children. And so that's kind of what has motivated me so much to work towards both expediting the process of doing documentation for historical structures, cultural landscapes, all of it, as well as expediting the process of prospecting archaeology to find where sites are. And all of these things are possible with 3D modeling and with drones, with remote sensing, with all this new technology that's coming about. It's kind of just getting people behind it and getting them to realize, like, the fear that I feel of wanting to take all of it in so that future generations can see it before it is too late. So just to kind of illustrate more on that point, since New Orleans is not quite a coastal city, this is a map from a report that came out last year from the NASA Jet Propulsion Laboratory about subsidence in New Orleans. And the star is the site of the Royal Street House that I modeled, which is, according to this map, experiencing between 10 to 20 millimeters of subsidence every year, which is wild. Like, it's just like, it's a crazy number, and it's a crazy thing for me to see these maps and to know what is coming and to know that few people are doing much about it to preserve it. Either preserve the land. There's a lot of work in preserving the land and coastal restoration, but there doesn't seem to be very much focus on all the resources that exist in Louisiana and New Orleans specifically. So to that, here's a map of the historic districts that are managed by the city, by the Historic District Landmarks Commission, and I added that to offset this, because this is a pretty bad map, but this is all I could find. So these are the historic preservation, the National Register historic districts within New Orleans. As you can tell, it's pretty hard to find a place in New Orleans that's not in a National Register district. Literally the whole city is just teeming with history, teeming with structures that ought to be and deserve to be documented. And with the way that it is now, with traditional methods, there's no way that you can collect all of that information in the time that we are allotted here in this state. So to that, here are some other sites that I am interested in looking at for the sake of, Louisiana disappearing. One of which being Fort Proctor, which is well on its way. It's a submerged 19th century fort, and that site is also listed on the National Register, so it would have, a much bigger implication than modeling my old apartment. Fort Macomb also is another 19th century fort that's located in New Orleans East. I thought that one was interesting because it was used as the site for Carcosa on that True Detective Season 1, if any of y'all saw it. And Holt Cemetery, which is what I'm writing my thesis on. It's the only below-ground cemetery in the actual city of New Orleans, and it's really interesting because it's made of it's not decorated in the above-ground stone structures that most of us are used to seeing with New Orleans cemeteries. It's a lot more handmade, and I hate the word authentic, but I want to say authentic New Orleans as far as cemetery and burial art go. With that, I'm trying to use my drone to make an interactive map and to collect all the information, all the headstones, and have like a tool that people can go and view and query it, find their relatives, find famous people, find anyone they're interested in, as well as search it by the actual burial art style, which is something I think is cool. And I want to, with that, incorporate 3D models of it's a long shot. It's connecting with the families, asking their permission, etc. But I was hoping to find interesting artifacts at the grave sites, make really quick 3D models of them in the field, and then be able to incorporate that into this. But that's all future work. Things I'm thinking of to basically document before they're gone. That's what is motivating me to be here and to do this now. This is a video of Fort Proctor, just to kind of put into perspective. I've been told by a lot of people that you don't know what's going on. You can't feel the crisis in Louisiana, in coastal Louisiana, until you actually fly over the coast and you see how, if you look at this on Google Maps, it shows it as solid land. And whenever you see it in this, it's quite clear that it's not. It's disappearing. So this is from an airplane. My professor took this and sent it to me of Fort Proctor, just to kind of show you guys. And thank you. That's all.